Example 14.2, determine the structure stiffness matrix for the truss shown in Fig 14-8a. AE is constant. This truss is station-scally indeterminate. Each joint and member are identified numerically. Members are specified by a number within a square. Nodes are specified within a circle. Near end and far ends are indicated by the arrows along the members. Each degree of freedom is a displacement. There are 4 members, with 2 degrees of freedom per each member, then there are 8 degrees of freedom for the truss. And so the global stiffness matrix K will be an 8 by 8 matrix. EHRE are the displacement 1, 2, 3, and 4 are unconstrained displacements. And these 4 unconstrained displacements, or these 4 degrees of freedom, are code numbered first. Displacements 5, 6, 7 and 8 are constrained and located at the supports, so their values are all equal to 0. In order to keep all the joint coordinates positive, the origin of the global coordinates is chosen at the node 1. Now we will make a table for each member of our truss, including their near point, far point for each x and y coordinates, their length, their lambda x and lambda y coefficients, and their related degrees of freedom. Member 1 is horizontal, then their lambda y, the vertical coefficient, will be equal to 0. Member 1 is made up of 2 nodes, 1 and 2, then from 4 degrees of freedom, 1, 2 and 5, 6. Member 2, from 2 nodes 1 and 3, is made up of 4 degrees of freedom, 1, 2 and 7 and 8, and is 45 degrees above the horizontal plane, then its lambda x and lambda y will be equal to 0.7071. Member 3, vertical, then lambda x equals 0 and is made up of the DOF 1, 2 and 3 and 4. Member 4, horizontal, then lambda y equals 0 and made up of DOF 3, 4, 7 and 8. Member 5, 45 degree with negative slope, then lambda y is negative, DOF 3, 4, 5, 6. Member 6, DOF 5, 6, 7, 8, vertical, then lambda x equals 0. Equation 14.16 is used to calculate the component stiffness matrix for each member. For each member, from their lambda x, lambda y, length, and their DOF, we will generate a matrix small k, 4 by 4, based on the formula. And from the matrix 4 by 4, we will rearrange the coefficients into a bigger matrix K of 8 by 8. Finally, we assemble the global stiffness matrix K by adding all the 6 component matrix K.